Refrigerator. What determines the price of refrigerators? Analysts are interested in understanding which factors most influence the cost of modern refrigerators. A data set was collected from a major appliance retailer, including details such as operating cost, fridge size, freezer size, number of shelves, total shelf square footage, number of features, and color, white or stainless steel. Conduct the appropriate hypothesis test to determine which of these variables can be used to predict refrigerator cost. Use an alpha of 0.05. You will need to use binary encoding for the variable color. Code white as a 1 and stainless steel as a 0. Data is in the next tab. Complete the coefficient table in this tab for the final model. If a variable was not included in the final model because its p-value was too big, put in A for the coefficient and p-value. Okay, so let's come over here and zoom in again. And the first thing we have to do is fix the binary encoding. So we're going to insert a column here. Again, call it color because this will be the binary encoded color. We'll say equals if this value is equal to white, because I'll capitalize it. I don't think it matters. And it's a 1, otherwise 0. Okay, now we're ready to do DATP. So our Y range, okay, this gotta make that a bit longer to here. And then our X range is gonna be all of these except for the qualitative column that was binary encoded. We do have labels. Confidence interval 95% because of alpha 0.05. And our output range, okay, let's pick a spot right there. Click OK. Remember, while still highlighted, come over here and go to number format. All right. So which is our least significant predictor? Well, 2 of them at this point wouldn't qualify, but this 0.61 is the worst one, so we're going to eliminate it first. So we come right back to the DATP. Oh, actually, before we do that, let's eliminate that column. So we're getting rid of shelf square footage. There we go. Delete that. And now let's come back to DATP. And so our X range is going to have to be reduced, because remember when we eliminated it, it still comes out too far because it thinks that column is still there, even though it's not. So we re-highlight the X range, and we also have to change our Y range to be here. Click OK. I don't know what that's all about. Oh, somehow I messed up. Let's try that again. Y range is right there. And again, while still highlighted, come back here and pick number. All right. And still, number of features is still greater than 0.05. Right, so we got to eliminate that one as well. That's our next one to go. Delete that. And we'll run it again. Data analysis. Y range is still going to be fine, but the X range has to be reduced by 1 again. All this is good, but the location is going to be here. And while still highlighted, change the formatting. And wonderful. Everything's a significant predictor, except the intercept. But we don't care about that. We're obviously not going to get rid of the intercept. We need that to graph the line. So we don't care that it's not significant because we can't get rid of it. We can only get rid of coefficients of the predictors. All right, while this is still highlighted, we'll copy it, paste it back over here. Okay, apparently there. Now let's try it. Well, what's going on here? Maybe I didn't copy it well. Let's come back over. Control C. Back here. Place final model. All right. And now let's begin. Equals intercept equals the p-value equals operating cost intercept coefficient equals p-value equals fridge size coefficient fridge size p-value freezer size coefficient freezer size p-value. Interesting, that looks like it's the strongest predictor. Freezer size, the biggest number. And number of shelves coefficient, number of shelves, p-value. Then we skip all the way to color. So these are going to be NAs. Equals color, coefficient, color p-value, and the standard error is there. And then these are NAs. Okay, so our predicted cost is going to be equal to the intercept locked plus operating cost locked times operating cost plus fridge size locked times fridge size plus freezer size locked times freezer size plus number of shelves locked times number of shelves plus, and now we're going to skip these two because those are NAs and go here to color white locked times if it is white. Then copy it down. And remember, this last one actually is the value of the coefficient until these are filled in, because right now they're being interpreted as zeros on that last line. And now we can get our prediction interval. So it's going to be equal to this value minus 2 times standard error locked. Drag that down, and on this side it's that prediction plus 2 times the standard error. All right, what's the interpretation of the standard error? On average, predicted differs from actual by $87. That's A. What's the interpretation of adjusted R squared? Well, what's its value? 0.68, which is it's 67.7 rounded. All right. And B, we can predict about 67% of the variation in price by the predictors in our model. What's the interpretation of the slope for color? I like this one. So it's a negative 1.08, which means, remember, and this will only show up when the color is white, because it'll be 1 times that. Because if it was stainless steel, it'd be 0 times that, in which case it wouldn't show up. So if the color is white, then the price is going to be $108 less. And that's B. And use the experiment row for operating cost of 60. What else? Fridge size 14, 4, 2. 14, 4, 2, 2. And white color. And notice we don't even have to have values for these two because they wouldn't help with the prediction anyway. It's going to be 746.29, which is C. Okay, what's the interpretation of the slope for freezer size? So that's positive. So as the freezer size increases, then the value, freezer size increases by 1. I guess that's 1 probably cubic foot. The value of the refrigerator goes up by $145. So let's see which one says that. Yeah, and it's always going to be holding all other factors constant. So there it is, D. Slope for operating cost, that one's negative. So as the operating cost increases by 1, the value of the refrigerator, or the price, decreases by $8.57. And that looks like A. And what's the correct regression equation? Okay, wow. So remember, negative, negative, positive, 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 and the last one was negative. Let's use that to kind of whittle it down. Everybody starts on negative, negative. Okay, so B's out because that's not negative. C's out because that's the wrong form. So it could be A or D, but even D is the wrong form. So it looks like it's going to be A, but let's just make sure. So negative plus negative plus negative, negative, positive, 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 and then the color was negative. So it looks like it's A. And what's the interpretation of the intercept? So it's C, be the price, though it's not actually meaningful in practice. All right, and we're all good.